Hi guys, I thought I'd send out a little video to help with 12.4 number 4, which asks you to develop the area of a trapezoid with base B and height H and also upper base A. We actually call those two lengths a base, even though they're only B is here on the bottom, but base is B and A. So they ask you to do it 4 different ways, and I'm just going to briefly summarize a little bit and hope that you go back and rewatch this if you need help. If you don't, you can skip it. So the first part says, show how to combine 2 copies of the trapezoid in figure 12.49 to make a parallelogram, and then use the formula for the area of a parallelogram to deduce the formula for the area of a trapezoid. So we know a parallelogram has shape like that, base B, height H. As you know from class, the area of a parallelogram is B times H. Again, from moving an additivity in class, we took that little triangle off and we moved it over there and found a rectangle with base B and height H. So what we do here with the trapezoids is we take another copy of the trapezoid, turn it upside down, kind of like that, put it next to the other trapezoid, and we see that we have a full length down there of A plus B. Still have the same height of H. So the area of that full parallelogram that we created is A plus B times H. But if we wanted just half of it being the being the trapezoid, we just take that area of the parallelogram, A plus B times H, and divide by 2. And that we have the area of the one trapezoid. The second one has the same idea, but we're doing it a little differently. It says show how to cut off portions of the top part and combine these portions with the bottom part, so as to make one or several parallelograms or rectangles, each of which has one side of length 1/2 H. Again, we talked about that in class when we did the triangles. This is H. So if we're talking about 1/2 of H, we cut that in half. We just say, okay, there's half of H. And so we say, how do we make our new figure have half H as its height? Well, so we say, there we go. We look at this, what's happening in the upper part, and we say, okay, that guy could come down here. This guy, that little triangle, could fill in there. My drawing's not perfectly to scale, but see what would happen. And this little rectangle up there, which has dimensions A and half of the height, could come down here and fill in right there. So now all of this upper part has been moved. And now I have this long, skinny rectangle with a height of H over 2 and a full base of A plus B. And that is just all of the parts of the trapezoid moved around. Again, the little rectangle up here came down there. The triangle here came here. Again, not perfectly drawn. The triangle here came down here. So our final area is A plus B times H over 2, which happens to be the same thing we got in A of a different form. Part C takes a look at the trapezoid as being kind of this sum of 2 triangles. If we look closely at it, we have this triangle right here with base A, and this triangle right here with base B. Both of them have height h. If you remember how to find the height, which we practiced on Tuesday, the height of the triangle with base A, we'd extend that base. We'd go to the opposite vertex as A, and we'd drop a perpendicular to that base, and we can see that that triangle, triangle 1, has height h as well. So the area of the trapezoid is equal to the area of triangle 1 plus the area of triangle 2. Another one. Triangle 1 has area 1/2 A, the base, times h, its height. Triangle 2 has area 1/2 B, the base, times h, the height. And if we factor out the stuff we know, or stuff which is common, we have 1/2 h times a plus b. And that's equivalent to what we got in in B and A. Looks a little bit different, but it's the same thing. Last question says, hey, do you know of any other parts, any other methods of deducing the formula for the area of a trapezoid by using moving and additivity principles? Well, I think if we take a look at this trapezoid, we can see another way to cut and move. Like if we cut this little triangle off on the end, we could probably put it up there, but it would have to be this distance from there to there. That midpoint would have to be the same. So if I cut him off and move him up there, and if I cut this guy off, blue guy off, and I move him up there, I'm now looking at a rectangle. So these two triangles at the end are now gone, and I have a rectangle, but the question is, what's the base length? Since we really took the difference of A and B, these extra little lengths, we kind of cut them in half. We really went halfway in between that extra part. We created really the average between A and B here, and we know that when we find an average, we add the two lengths and we divide by 2. And then to find the area of the rectangle, we take that average and we'd multiply it by the height h. Again, same thing as previous problems, C, B, and A, but a slightly different looking form. I hope this helps. This is, by the way, is not the only fourth method of finding the area of a trapezoid, but it's one of them, by considering the average length between A and B, and that's one of the ways that I always remember the area of a trapezoid. Hope that helps.